170 milliliters per minute, something like that.
The sheet there.
Right, actually even more. I think it's 600, right? So then the problem is you already have a factor of 100 that you're losing. So you're losing sensitivity going on.
I think 100 in parallel on this.
Right, yeah, right. Well, so in parallel, you mean the virtual impactors, right? Yeah, but see, then that adds to the noise. That's the problem. Yeah, yeah. And with respect to the timeline, well, so the nice thing about microfabrication, it usually is a batch process. Right? So once you have a device that works, that's fully characterized, you can normally very quickly translate it to something that can be mass-produced, because in essence, you're already mass-producing many of them. We're never fabricating one. We're fabricating many of these devices. I mean, there is still the issue of fully characterizing the performance and seeing what the long-term drift is, factors with respect to humidity, temperature, and in fact, we are actively analyzing some of those. But I would say, I would expect if we put our minds to it, we're maybe half a year from being able to answer some of these things, and then maybe seeing some of these instruments.
I was actually also asking you about cost.
Oh, the cost, right. Yeah, so these things can actually be really inexpensive. So the resonator, that mass-sensitive resonator, right? The cost of that is difficult to quantify, but if we would make it ourselves, because it's actually made by another company and they it's proprietary. If we would make it ourselves, I would estimate the cost of that to be maybe 20 cents, something like that, right? So 20 cents, the cost of the silicon and the rest of it, maybe a few dollars, right? In quantities of many. Some electronics added to it, right? Some signal processing. So I would say we can easily create a device that's maybe $10, $20